Now we are going to see another device that is closely related to the cyclotron, and this is called the synchrotron. What happens when an electron moves along a path that is controlled by a magnetic field and makes it to describe circles? What happens in this case is that there is acceleration. Although the velocity of the electron is constant, along the path there is an acceleration. And you know now that if there's acceleration, then the electron will be radiating, will be producing electromagnetic waves. And the cyclotron has to keep pumping, and all accelerators have to keep pumping their charges to maintain the paths, maintain them going along the circular paths. But fortunately, things are not so bad, because when there's radiation coming from those devices, this radiation tends to fall into the UV and X-ray regions of the spectrum. And what was considered to be a nuisance in the early times of the cyclotrons, then in the synchrotrons, this was considered to be an advantage. And people immediately realized, and this was the case in General Electric in the US, when in the late 40s they built the first synchrotron, and here you see the shape of it, that this was the fantastic light source that could produce very powerful and coherent lights. So normally synchrotrons are sometimes listed under this heading as light sources, and you can get information on this website. I'm going to show you the first animation of a synchrotron. This is taken from the European Synchrotron Radiation Facility. This is a large lab that is in France, in Grenoble, and it's just a joint venture of European countries where scientists from everywhere go there just to do research. I'm going to run the animation, and then I will try to comment on this. You will see a bunch of electrons that are injected into this loop. You will see that they will be accelerating on the synchrotron, and then they will move to the outer one, and in there, across the bending, some ingenious device will just distract the light in a way that will be useful to everyone. Once again, and I'll see if I can stop it along the path. If you look at this picture, you will see there are two loops in there. This is a typical situation. The inner loop was an older synchrotron that was small in size. And when they built the larger one, they just kept this one to be a pumping source for the following one. The electrons are injected with very powerful microwave tubes along this linear path, and they are accelerated. And once they enter here, they will be accelerated and again and again. And when they have enough velocity, they will be launched to the larger one. And you can see how the motion and the simulation increases this velocity. And in the outer one, they will be exploited for any practical purpose of interest. This is a synchrotron that was recently inaugurated and is close to us. It's the ALBA synchrotron that is in Barcelona, near the campus of the University of the Autonomous University. And you can get plenty of information on this website. Some basic parameters for this synchrotron is that it has a ring circumference of about 270 meters. the beam energy is 3,000 million electron volts. We use giga electron volts here. The current in the ring is around 400 milliamps, and the frequency is 1.1. The revolution frequency is around 1.1 megahertz. And it produces very powerful, which are called normally beam lines from X-rays to 2.2 angstroms, and they can be tuned for different applications. The synchrotron will try to serve the scientific community and also for industrial purposes, the industry. With those numbers there, for this power, this means that the energy of the electrons, when you work the formula, you will see that the mass of the electron has this value, and that means that it's 6,000 times the value of the mass at rest. That means that in the ring, at the end, the velocity of the electrons is closer to the velocity of light, and they just differ in 14 parts in a billion. So we are under very strong relativistic conditions. Now, as a summary for future use, if you need some of the data, they are available everywhere, but here you have them condensed, some values that may be of interest. There we have the electron charge, the charge of the electron, the mass of the electron at rest, Planck's constant, the proton and the neutron rest mass, the velocity of light, and you have two energies here. This is the electron volt, which is just the energy needed to move an electron across 1 volt, which is a value of interest in some electronic applications, and this is the equivalent in joules. And also you have at the bottom the electron rest energy. This is the 500 kilo electron volts, and if you compare this with the giga electron volts in the ring, you will see why the acceleration is